I am Adarsh. I am chemistry faculty. Today discussing 11th standard organic chemistry. Today topic alkyl halides. Alkyl halides derived from alkanes. So in alkanes, one or two or three hydrogens replaced by halogen atoms to form alkyl halides. Suppose we have to take methane. In methane, one hydrogen replaced by one halogen, we produce methyl halide. Then methyl halide, one hydrogen replaced by one halogen, we produce dihalomethane. In dihalomethane, one hydrogen replaced by one halogen atom, it produces trihalomethane. In trihalomethane, one hydrogen replaced by halogen, it produces tetrahalomethane. So, alkyl halides are derived from alkanes. So, in alkanes, all hydrogens replaced by halogen atoms, it produces alkyl halides. So, alkyl halides is of three types. So, primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. Alkyl halides can be classified into monohalogen, halides. Continue. Now, alkyl halides can be classified into monohalogen, compounds, dihalogen compounds, and trihalogen compounds, and polyhalogen compounds. Suppose you have to take monohalogen compounds. For example, CH3X. CH3X is the monohalogen compound. C2H4. X2 is the dihalogen compound. CHX3 is the trihalogen compound. So polyhalogen compounds. Suppose C2 X6 is the polyhalogen compound. So halogen compounds is of monohalogen compounds, dihalogen compounds, trihalogen compounds, and polyhalogen compounds. Nomenclature of alkyl halides. Alkyl halides, IUPAC name and a common name. Suppose CH3Cl, IUPAC name is methyl chloromethane. Common name is methyl chloride. Next one, CH3CH2Cl, IUPAC name is chloroethane. Common name is ethyl chloride. Suppose CH3, CH2, CH2, Cl, IUPAC name is chloroethane. propane. Common name is propyl chloride. Propyl chloride. Suppose CH3, CH, Cl, CH3. IUPAC name is 2-chloropropane. 2-chloropropane. Common name is isopropyl chloride. Isopropyl chloride. Now, preparation of alkyl halides. Preparation of ethyl chloride. Ethyl chloride molecular formula is C2H5Cl. First preparation method from ethyl alcohol. First process, gross process. In this process, when ethyl alcohol react with HCl in presence of anhydrous ZnCl2, it produces ethyl chloride, C2H5Cl, ethyl chloride. This process is known as the gross process. So in this process, when ethyl alcohol react with concentrated HCl and anhydrous ZnCl2 to form ethyl chloride, then concentrated HCl and anhydrous ZnCl2 is called Lucas reagent. Lucas reagent used for detection of primary, secondary and tertiary alkyl halides. Next, second method, by the action of phosphorus trichloride, phosphorus pentachloride and thionyl chloride, SOCl2. When ethyl alcohol react with phosphorus trichloride to form ethyl chloride and H3PO3. So in this molecule, in reactant side, 3 chlorine atoms is there. So 3. The overall equation is balanced. Next, ethyl alcohol react with PCl5. It produces ethyl chloride plus POCl3 plus HCl. Ethyl chloride, POCl3 means phosphorus oxychloride and HCl. Then ethyl alcohol react with thionyl chloride. So in this process, ethyl alcohol react with thionyl chloride. It produce ethyl chloride plus SO2 plus HCl. Now, third preparation from ethylene. Ethylene molecular formula is CH2 double bond CH2. When ethylene react with HCl, it produces ethyl chloride. Fourth preparation from ethane. Ethane react with chlorine in presence of sunlight at 400 degrees centigrade. Ethane react with chlorine in presence of sunlight at 400 degrees centigrade. It produces ethyl chloride and HCl. On large scale of ethyl chloride can be prepared from ethane. Ethane react with chlorine at 420 degrees centigrade. It produces large amount of ethyl chloride is obtained. Now, chemical properties of ethyl chloride. First one, reaction with aqueous KOH. When ethyl chloride react with KOH, aqueous KOH, it produces ethyl alcohol and KCl. Then reaction with alcoholic KOH, when ethyl chloride react with alcoholic KOH, undergoes dehydrohallucination to form ethylene. This reaction is known as dehydrohallucination reaction. Dehydrohallucination means removal of water molecule and alkyl halide. When ethyl chloride react with alcoholic KOH, it produces ethene and KCl and H2O. This reaction is known as dehydrohallucination reaction. Reaction with KCN, potassium cyanide. When ethyl chloride react with KCN, it produces ethyl cyanide and KCl. Then reaction with AgCN, silver cyanide. Ethyl chloride react with AgCN to form ethyl isocyanide and silver chloride. So what is the difference between KCN and AgCN? So KCN react with ethyl chloride, it produces ethyl cyanide, but ethyl chloride react with AgCN, it produces ethyl isocyanide. Then ethyl cyanide and ethyl isocyanide exhibit functional group isomerism. So in this topic, KCN is a ionic compound. KCN is a ionic compound, but AgCN is a covalent compound. So KCN easily ionized K plus and Cn minus ion, K plus and Cn minus ion, but AgCN does not ionize, so it produces isocyanide group. KCN produces cyanide group. Next, reaction with sodium metal. Reaction with sodium metal. When ethyl chloride react with sodium metal in presence of dry ether, it produces alkanes, nothing but butane. So 2 moles of ethyl chloride react with 2 moles of sodium in presence of dry ether to form butane, and NaCl, 2NaCl. This reaction is known as Wood's reaction. This reaction is known as Wood's reaction. So when ethyl chloride react with the sodium metal in presence of dry ether to form alkanes, nothing but butane. This reaction is known as Wood's reaction. Next one, reaction with magnesium. When ethyl chloride react with the magnesium, it produces ethyl magnesium chloride. Ethyl magnesium chloride is known as Grignard reagent. Grignard reagent used for the preparation of primary, secondary and tertiary alcohols. Then silver acetate. When ethyl chloride react with the silver acetate, it produces ethyl acetate plus AgCl. So reaction with the silver acetate, ethyl chloride react with the silver acetate to form ethyl acetate and AgCl. Now reduction reactions. Ethyl chloride undergoes reduction in presence of lithium aluminum hydride or sodium borohydride or nickel, platinum or palladium. Those are examples for reduction reagents: lithium aluminum hydride, sodium borohydride, nickel, platinum, palladium, etc. So ethyl chloride undergoes reduction in presence of reduction reagent. It produces alkane. So ethyl chloride react with lithium aluminum hydride. It produces ethane. This reaction is known as reduction reaction.